Hello and happy Tuesday to you all. Today we're going to look at just a few new examples in 7.4. We've covered mostly everything from 7.4, but there's a few types of problems that we need to pick up today. These are going to be a little bit different from yesterday. The big difference from yesterday to today, as you see on the screen, is we have to check if anything can be factored first, which I know that is great news for you all. Other than that, everything else is pretty much going to be the same. So first thing we're going to do is check if anything can be factored. Then we're going to check for any restrictions, which was the new thing yesterday. Then today we're actually going to have to find the least common denominator for all of these, which is something we didn't have to do yesterday because they were all proportions. You'll see when you get to your homework today that most of these are not going to be proportions. So we're going to have to use the methods from Friday. So we're going to find the least common denominator, multiply everything by that least common denominator, cancel out the fractions, and solve from there. So first example we're going to look at today, 3 over x minus 4 plus 2 over x squared minus 16 equals 0. Okay, so first thing, like I said, the new thing today is we have to see if anything can be factored first. So this 3 over x minus 4, I cannot do anything with that. It's all going to say 3 over x minus 4. Now, this second term here, the 2, can't change much with the 2. But this x squared minus 16, hopefully you notice I have two terms. I have a difference of squares. I have x squared and 4 squared. That can be factored into x plus 4, x minus 4. So notice now I have nothing else that can be factored, so we're ready to move on to kind of what we started yesterday. So we're going to look for any restrictions. So if I check out this first fraction here, 3 over x minus 4, I'm thinking, okay, well, what would x have to be if that denominator was 0? Hopefully we're saying it would be 4, so I know x cannot equal 4. If I look at the second fraction, notice one of my restrictions is going to be the same, okay? I'm going to have that x minus 4 can't be 4. But this one here, I see that if this one were 0 and 0 times this, it's going to give me 0. So I also have to look at this one. So if I look at that factor, I would also have to include negative 4. If I plugged in 4, I would get 0 in both fractions actually. If I plugged in negative 4, this fraction denominator would be 0. So my two restrictions are 4 and negative 4. And then next thing that we want to do is we want to check for the least common denominator. I introduced this yesterday. Since I have a quantity in my numerator, I have to look at each individual fraction and figure out what would get rid of my fraction. So this first fraction here, the only thing that's making it a fraction is this x minus 4. So if I look just at that first fraction, the least common denominator just for that fraction would be x minus 4. Now if I look at this fraction here, notice that I would need to get rid of an x minus 4 in this fraction too. Well, I already have the x minus 4, but I also need to get rid of an x plus 4. So my least common denominator is going to be x plus 4, x minus 4. Doesn't really matter the order, you just need to have both of them. The next thing is going to be like what we did on Friday. So now we're going to take each of these terms. We're actually going to multiply both sides of my equation by that least common denominator, which is x minus 4, x plus 4, and then this side by x minus 4, x plus 4. And we're going to distribute it to both terms, just like Friday. So I have x minus 4 times x plus 4 times 3 over x minus 4. And then I have x minus 4 times x plus 4 times 2 over x plus 4, x minus 4. And on the right-hand side, luckily, 0 times x minus 4, x plus 4, that's just going to be 0. Let me get some of this stuff out of the way. Move this up here. Okay, so looking at what I'm left with, we're going to go back and we're going to cancel out our denominators. Now this part's actually going to be easy because all you really have to do is look just at your denominators. So this x plus 4, or sorry, this x minus 4 will cancel out with that x minus 4. I'm left with 3 times x plus 4. So if I distribute that 3, we have 3x plus 12. For this second fraction here, if I look at my denominator, the x plus 4's cancel out, the x minus 4's cancel out. Since both of those cancel out, I'm just left with plus 2, and on the right-hand side I have 0. Notice, once again, just like before, I have no more fractions, so I can go ahead and solve. So I have 3x plus 14 equals 0. Subtract 14 from both sides, so I have 3x equals negative 14. Divide both sides by 3. We should get x equals negative 14 thirds. And just double check. At the very beginning we said x couldn't be 4 or negative 4. Well, this is neither of them, so that would be an okay answer. Okay, let's move on to our second example. Our second example, we're going to have 2 over b squared minus b minus 2 over b minus 1 equals 1. So remember, the first thing we need to do is we need to make sure everything's factored. So hopefully you're noticing that this denominator here, that's not factored. So we're going to have to factor that. So I have 2 over, always check for a least common denominator first, a greatest common factor. Those have a b in common. So when I factor out a b, I'm left with b minus 1. And then the second one, we're just going to leave it as 2 over b minus 1 equals 1. Now that everything's factored, let's look for any restrictions. Now you have to be careful here, because if I look at this one here, remember what we're really doing is if you're not quite sure exactly what it would be, you would set your denominator equals to 0. So for this one, if I say, okay, well I know that b times b minus 1 can't equal 0, you might notice that this looks like a factored expression, which makes sense because that's what we just did. So if it's a factored expression, once it's factored, we set each factor equal to 0, and we solve. So this tells me, remember we're talking about our restrictions here, the b cannot be 0, and b cannot be 1. So those two I have restrictions already. And if I look here at this second one, if I have b minus 1, well, for that one, it would just be b minus 1. So my restrictions are 0 and 1. And then the next thing we'd look for is the least common denominator. So for the least common denominator, remember we have to take into account everything that we'd have to get rid of. So for this one, I'm going to have to multiply by that whole denominator to get rid of it. The exact same thing. I'd have to multiply by b times b minus 1. The only thing that's going to cancel that out is b times b minus 1. Now luckily, if I were to multiply by b times b minus 1, notice that b minus 1 would cancel out in that second fraction. So my least common denominator is just going to stay b times b minus 1. So the next part, just like before, we're going to multiply by that least common denominator, which I would end up distributing to each term. So we're going to end up with b times b minus 1 times 2 over b times b minus 1 minus b times b minus 1 times 2 over b minus 1 equals b times b minus 1 times 1. Okay, let's move some of this stuff up there. Okay, and let's go back and cancel out our denominators. So notice for that first term, the b's cancel out, and the b minus 1's cancel out, and you're left with a 2. For the second one, only the b minus 1 cancels out. Negative b times 2 gives me a minus 2b. Over here on the right-hand side, that times 1 is just going to give me itself, but I can go ahead and distribute that b. So we should have b squared minus b. Notice I have a squared term, which means I'm going to have to solve by factoring. My square term's already positive, so we're going to leave it where it's at. We're going to move everything towards it. So I'm going to add 2b and subtract 2. So add 2b, subtract 2. So I have 0 equals b squared plus b minus 2. Now we'd be ready to factor. I have 3 terms. There is no square in front, square in back. So I'd look for factors of c that add to b. So we'd be looking for factors of negative 2 that add to 1, which hopefully you know would be 2 and negative 1. So to factor that, we would say b plus 2, b minus 1. Once it's factored, we can set each factor equal to 0 and solve. So b plus 2 equals 0, b minus 1 equals 0. So I know that b could be negative 2 or b could be 1. But if you remember at the very, very beginning, we said my restrictions were 0 and 1. I said that b could not be 1, so we're actually going to throw out that 1. My only answer would be -2. Okay, and 1. Number 3, let's try n plus 1 over n plus 2 minus 10 over n squared minus 4 equals 0. First thing that's new today, we need to make sure everything's factored. That first fraction, n plus 1 over n plus 2, that's just going to stay like that. But that second fraction, that n squared minus 4, that's a difference of squares. We can factor that into an n plus 2, n minus 2, which equals 0. Okay, so next let's look at any restrictions. So looking at that first fraction, hopefully we know that if I look at that denominator, if n were -2, my denominator would be 0, which we know doesn't work, so I know n cannot equal 2. Looking at that second fraction, if either one of these factors equals 0, that whole denominator is going to equal 0. For this first one, it's going to be the same as my first fraction, -2. But for this second one here, it also tells me that n could also not be 2. So I have 2 restrictions here. Next, let's look for the least common denominator. So if I look at that first fraction, to make that first fraction go away, I need to multiply by n plus 2. So I know n plus 2 is going to be part of my least common denominator. This second fraction, I would need to multiply by n plus 2 times n minus 2. Notice I already have the n plus 2. I only need the n minus 2. I don't have to repeat the n plus 2. It's unnecessary. So, just like before, we're going to multiply both sides of the equation by this least common denominator. So I'm going to take n plus 2 times n minus 2 times n plus 1 over n plus 2 minus n plus 2 times n minus 2 times 10 over n plus 2 n minus 2 equals 0 times my least common denominator. Lucky again is just going to give me 0. So let's go back. Let's cancel out our denominators. My n plus 2 cancels out. This time, I'm actually going to leave it as n minus 2 times n plus 1, and we'll deal with that here in just a minute. For my second fraction, the n plus 2's cancel out, the n minus 2's cancel out. I'm only left with minus 10, which equals 0. What I'm actually going to have to do for this one is I'm going to have to FOIL this out and then simplify before I can factor. So if I FOIL this out, we get n squared plus n minus 2n minus 2, and then we've still got that minus 10 equals 0. Let's go ahead and combine like terms. So I have n squared. When I have n minus 2n, I get a minus n. -2 minus 10 gives me -12, which equals 0. Now we'd be ready to factor. I have 3 terms. I don't have a square in front, square in back, and it's just x squared. So we're looking for factors of c that add to b, so factors of a -12 that add to -1, which would be -4 and 3. So I have n minus 4, n plus 3, which equals 0. So if I set each of these equal to 0, we should get n equals 4, or n equals -3. My restrictions at the very beginning, we said that n could not equal 2 or -2, so 4 and -3 would both work.